Scholars, let's continue reviewing some factoring. This time, let's attempt to factor trinomials of the form ax squared plus bx plus c. Okay. I'm going to those three subdivisions. What if the leading coefficient a is 1? Then we'll introduce the AC method and then a special case. So let's try first when a equals 1. Pretty much what we have to do is we have to recall when we do the FOIL, when we distribute, we attempt to, well, x squared, of course, x and x. Of course, you're going to have here either plus or minus. We still don't know. But the strategy is as follows. We need to find factors of the value of c such that when I do the O and the I of the FOIL, it will give you the middle term. Namely, when I multiply this number times x, and I add it to this number times x, will give me the middle number b. Okay, so let's try a couple of examples. When leading coefficient a equals 1. Okay, let's start with these two examples. Of course, it's the trinomial factors. It has to fact. First, always look for the greatest common factor. Anything else, that's the first thing that we need to do, to see if we can factor out something before we continue attempting this technique. So if there is any common factor for each of the terms, we need to factor it out. So let's assume we already did that, which in this case we did. There's no common factor. So now this is the general strategy. We need to look for C. In this case, C is positive. That means that these two signs have to be the same. If the C is negative, the signs will be different, 1 plus, 1 minus. Of course, since I'm looking for B to be positive, so I need both signs to be positive. Now we need to look for factors of 12 that will give me 7 when I add them. Of course, we have 12 times 1, 6 times 2, 4 times 3. If I were to plug in 12 here and 1 here, when I distribute, I get 12 times x, 12x, 1 times x, 1x. When I add them, 12 plus 1, 13, which is not 7. So, of course, we can do the same thing for 6 times 2. So the candidate will be, of course, 4 times 3. 4 times x, that would be 4x. 3 times x, 3x, 3 plus 4, 7x. Check. In this case, again, we need to find factors of 15. Notice that 15 is positive, b is positive, so both signs should be positive. Factors of 15, 15 times 1, or 5 times 3. 5 times 3 will be the proper candidate. 5 times 3, and we are done. What if we have the following examples? What about these other two examples? Once again, no greatest common factor. So we're looking for factors of 28. That gives me 11. Notice in this case, C is positive, so the signs have to be the same. However, since I'm looking for negative 11 when we add those, so we need both of them to be negative. Factors of 28, that when we add, gives me 11. Of course, we have 28 times 1, 14 times 2, 7 times 4. And 7 plus 4 would be 11. These are my two candidates here. That would be negative 7, negative 4. Negative 7 times x, that would be negative 7x. Negative 4 times x, that would be minus 4x. Minus 7 minus 4, negative 11. Same here. 10b squared is positive. We are our ways to get negative, so I need both of them to be negative. Factors of 10, that gives me negative 11, where there are not that many either. 5 times 2 or 10 times 1. So the candidate will be, of course, 10 times 1, because 10 plus 1, it will be 11. So in this case, we need 10b and then 1b, which normally we don't write the 1 and do it here on purpose. So negative 10 times 8 minus 10a minus 1, that would be 10ab. So the If we avoid the 1, it will simply be A minus B. Thank you. 2 more examples. If I have h squared plus 4h minus 12, now my c is negative. Therefore, I need both, not both, I need different signs, one plus and one minus. Again, factors of 12, that when I add them or subtract, in this case, gives me 4. Of course, we have 12 times 1, 6 times 2, 4 times 3, 6 times 2 will be the candidate. 6 minus 2 will be 4. Notice that 4 is positive, so I need the 6 to be positive and the 2 negative. 6 minus 2, 4. Here, I need to find, well, my C is negative 4, negative 24. Again, the signs are different. Looking for negative 5. Of course, I know that 24 times 1, 12 times 2, 6 times 4, 8 times 3 will be a good candidate. So on purpose, I'm going to put the 8 here and the 3 here to see what happens. 8 times x will be 8x. 3 negative 3 times x minus 3x. When I add those, 8 minus 3 will be plus 5. And I need negative 5. Also, we're so close, we can either switch the sign or the numbers. That means that the 3 should be here and the 8 here, and that will do it. Same thing here. 6 negative, different signs. Factors of 9, that gives me 8 when I add them. 9 times 1, 9 minus 1. 8 is negative, so I need my 9 to be negative and the 1 positive. But I've missed the t. A t and 1t, which of course we don't write 1t. We could say r plus t. It's an invisible 1, the coefficient is 1. And that will do it. Negative 9 rt, positive 1 rt, negative 9 plus 1, negative 8. And that will do it. Okay, let's wrap up this lesson with 4 more examples. Look at the first one, y squared minus 6y plus 15. Multiplication of 2 binomials. 15 is positive, b is negative, so I need my 2 signs to be the same. In this case, both negative. Factors of 15, it's either 15 times 1 or 5 times 3. 15 times 1, 5 times 3. But notice that not all combination will give me negative 6. I am subtracting. So what do we say? Thanks, but no thanks. This trinomial cannot be factored, therefore we can call it prime. It will not be factored. Here my 18 is positive, b is positive, so the two of them better be positive. Factors of 18, either 18 times 1, 6 times 3, 9 times 2. No combination gives me 4. Therefore, what do we say? Thanks, but no thanks. This pop is also prime. What about these 2 examples? 2n squared minus 8n minus 42. Notice that we have a greatest common factor, 2. Always, always, always start by looking for the greatest common factor. So we proceed here to factor out the GCF. In this case, will be 2 to end up with what? N squared minus 4n minus half of 42. That would be 21. Now back to basics. So here, what do I have? N, 21 is negative. Therefore, these 2 signs have to be different. Factors of 21, that gives me 4. Well, 7 times 3 is 21. 7 minus 3 is 4. Notice that since 4 is the negative, I need the 7 to be the negative, 3 the positive, and don't forget the 2. Last but not least, greatest common factor, 5 times 1, 5 times 3, 5 times 10. We can always factor out a 5. So we have what? K squared. 15 divided by 5, that would be 3k minus 10. 5, parenthesis, parenthesis, k. The 10 is negative, therefore one is positive, the other one is negative. Okay, so we're looking for factors of 10, that gives me 3. 10 times, oh my God, 5 times 2 is 10. 5 minus 2 will be 3. Since my 3 is positive, I need the 5 to be positive and the 2 to be the negative. 5 times 2, 5 times negative 2 is negative 10. 5 times k, 5k, negative 10k, negative 2k. So 5k minus 2k equals 3k, which is maybe the term here. Thank you. Oh, that was bad here.